Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on 7E Part 2 assignment. We're going to start here with number 10. A stormwater drain has the shape illustrated. Determine the angle beta where the left-hand side meets with the bottom of the drain. So we're trying to figure out what this angle is right here. Now here's what's going to help us. These two are parallel lines right here, so that helps us out a lot. This distance right here is 3 meters, so we know if we drop a line straight down to this vertex right here, that also is going to be 3 meters. And we can do the same thing over here. If we drop a line straight down to this vertex, that will be 3 meters as well. And these all make nice little 90-degree angles in here. Okay, so what we can do is let's do this. Let's pull this part out right here and redraw it down there. And what we have here is this little teeny side up here, this side here that's 3, and then this long diagonal side, which we don't know. So this is 3 meters, and we know that, let's see, if this is 100 degrees and we made a 90-degree angle, 100 minus 90 leaves us that this is a 10-degree angle. Okay, now here's the thing. We need to know, in order to figure out this angle here, we need to know either this side or this side. Not really sure how we'd find that side, but this side right here, we know this whole length here is 5, and we know this is 2. So if we can figure out what this side is up here, we can add that to the 2, subtract it from 5, and that's what this side length here is going to have to be. Okay, so we want to figure out what this side is here. From this angle, that is the opposite side, and this is the adjacent side. So opposite and adjacent is tangent. So we know that tangent of 10 degrees has to equal opposite, which is x over 3. So we multiply both sides by 3, and this will give us 3 tangent of 10, which I just did earlier. That gives us 0.529. Okay, so x is going to equal 0.529. Okay, so this little chunk right here is 0.529. So since we know that whole thing is 5, and this is 2, and that's 0.529, if we take 5 and we subtract the 2 and the 0.529, then that will tell us what this section is right here. So that's going to be 5 minus 2.529. So let's figure out what that is. 5 minus 2.529 leaves us with 2.471. 2.471. So that is going to be this piece right here, 2.471. Kind of hard to read. So let's do another part here where we're going to pull this triangle out right here. Okay, so we'll do that over here. Let's see. We got this side here, which we just figured out is 2.471. That's a right angle. We don't know what that is, but we do know that this is 3 meters. So if we can figure out what this angle right here is, we can take that and add it to 90, and that's what angle beta will be. Okay, so from this angle, this is the opposite side, this is the adjacent side, so we're going to do tangent again. Tan theta is going to be opposite, which is 2.471 over adjacent, which is 3. So since we are looking for an angle, we're going to want to do second tangent. 2.471 divide by 3, and we get 39.5. 39.5 degrees. And then that's just this piece. This 39.5 is just this piece right here. So we got to add that to another 90. So we take 39.5 plus 90 is going to give us 129.5 degrees for angle beta. So beta equals 129.5 degrees. Okay? Okay, moving on to number 11. From an observer, O, who is 200 meters from a building, The angles of elevation to the bottom and top of a flagpole are 36 degrees and 38 degrees respectively. Find the height of the flagpole. Okay, here's how we want to look at this. We can figure out what the height of the building is, and we can figure out what the height of the building with the flagpole on it is. So if we find the height of the building and find the height of the building and the flagpole, we can subtract those two, and they'll tell us what the height of the flagpole is. So basically what we've got here is we've got the big triangle, big triangle minus the little bit smaller triangle. I'm struggling here. It's all right. Is going to equal just the little itty bitty flag. Okay? So let's do big triangle minus small triangle. Okay, so our big triangle is going to be, I'm just going to redraw this just so that we can see it all. Kind of, for me, it makes it easier. So the big angle there is 38 degrees. This is 200, and we're trying to figure out what that is, right? So that's opposite and adjacent. So that's going to be tangent. So we do tan 38 is going to equal opposite, which is question mark, over adjacent, which is 200. So we multiply both sides by 200, and that'll tell us how tall this big triangle here is. Okay, so we're going to do 200 tan 38. And that gives us 156.3, we'll call it, 156.3 for the building and the flag. Then the small triangle is going to be essentially the same thing, except for it's only got an angle of now 36 degrees. But that's still 200, and we're still looking for this side here. So that's going to be, from this angle here, that's the opposite. That's the adjacent. So it's going to be tangent 36 equals opposite, which is question mark, over adjacent, which is 200. So multiply both sides by 200. And we get that our question mark is going to be, instead of 200 tan 38, it's going to be 200 tan 36. Not 63. That was not close. 200 tan 36. There we go. I only did 20. One more time. 200 tangent 36. There we go. 145.3. So we're going to take 156.3 minus 145.3, and we're going to get an answer of what? 21 meters is the height of that flagpole. 11 meters. 156 minus 145 is 11. Let's write that a little bit more clear. There we go. 11 meters. Okay, we're going to take a look at setting up number 12 here, not finishing all the way to the end, but at least so you can see what the picture should look like here. So number 12, the angle of depression from the top of a 15-meter high cliff to a boat at sea is 2.7 degrees. How much closer to the cliff must the boat move for the angle of depression to become 4 degrees? So here's our cliff down here to the water. And then let's say here's our boat out here in the water. And it's saying that we've got an angle of depression from the top of the 15-meter high cliff. So this is 15 meters. We're going to just assume that that's a perfectly straight cliff, so to speak. And let's see, the angle of depression from the top of the cliff to the boat at sea is 2.7 degrees. So what we want to do is we want to think of our angle of depression. So always start with a perfectly horizontal line, and then our angle of depression is going to be down here to the boat. So this right here, angle of depression, which they're saying is 2.7 degrees. Now, fairly important on this to understand that these two lines here, the red line and the water line, are perfectly parallel. So this 2.7 here is also going to be 2.7 degrees right here as well, alternate interior angles, right? So that's going to help us out, because once we know that that is true, then what we can do is we can figure out that we now know that the distance from the boat to the cliff is what we're gonna be looking for here, right? We can figure out this distance, and then we know that the boat ends up getting closer to the cliff, right? So the boat now has moved, so it's only now it's a 4-degree angle, 4-degree angle of depression down to the boat. Okay, so just trying to talk and draw at the same time, which for me is not a good idea. But anyway, so we now know that the boat has moved closer to the cliff. So now we know that this angle is 4 degrees. So we know this angle here is also 4 degrees. Still a right angle. Still 15 meters. Now what we can do is we can figure out what... Oops. Let's try that again. Now we can figure out what this distance is here. Right, now maybe I'll call this y, and then what we'll want to do is we can actually use, since we have this angle, this side, we want this side, and then same thing down here. The only thing that's changing is our angle. Is we can take our big triangle, subtract the smaller triangle, and that should be, take the big triangle, this x here, minus the y, should give us the distance moved by the boat. Okay? Moving on to number 16. A circular clock has dots on its boundary which indicate the numbers 1 to 12. The dots representing 10 and 2 are 24 centimeters apart. Find the radius of the clock. Okay, so let's do this. We're looking for this here, right? Oops, that's an R. And we can draw this over here as another R. And look, this makes these are the same, so this makes an isosceles triangle here. Okay, so let's do this. I'm going to redraw this out here so we can draw into it a little bit better. Okay, so those are both R's. And then if we drop this straight down here at a 90-degree angle, that's going to cut this 24 in half and make this 12. So what we want to do is we want to try to figure out what these angles are in here. So really what we're trying to look for is what's the angle from 12 to 2. Okay, so from 12 to 2, that's 2 out of the 12 total hours on the clock, which is a sixth of, and a full circle is 360 degrees, right? So a sixth of 360, guess what? 36 divided by 6 is going to give us 60. So this angle right here is 60 degrees. This angle over here is also 60 degrees. And that's going to really be the big key for us figuring this out. Okay, so this is 60. We're trying to figure out what this side is, right? This radius right here is, right? This, on this triangle here, this is opposite. And this is hypotenuse. So opposite and hypotenuse is going to be sine. Sine of the angle, 60 degrees, is opposite, 12 over hypotenuse, which is r. So since the variable's in the denominator, we're going to switch sides here. R equals 12 divided by sine of 60. 12 divided by sine 60 gives us 13.9. And that's going to be centimeters. So the radius of that clock is going to be 13, about almost 14 centimeters. Okay. All right, moving on to number 17. Okay, the cube shown has sides of length 13 centimeters. So all of these, since it's a cube, all of these sides here are 13. Okay. find B to D. So if you want to take this thing and basically like rotate it and like look straight down on top of it, so so that we're going to look straight down on top, so it's going to look like this. We've got, it's going to help us find this thing here. So I'm going to look down on top, D, A, B, and C. So we were trying to figure out what, oops, sorry, D, B is, right? Or BD. So if we know that this is 13, we know this is 13. It's a cube, so that's got to be a right angle. So we can simply just do a squared plus b squared equals c squared, right? A squared plus b squared equals c squared. The important part on this is that the hypotenuse is what we're looking for. That's the c squared. So we'll do 13 squared plus 13 squared. Okay, so that's going to be 169 plus 169. So 169 times 2 is 338. So we want to square root both of those and get that C is going to be square root of our answer. Oops. Square root of 338. Let's try it that way since I messed that one up. 18.4, we'll call it. That's this diagonal, 18.4 centimeters. Okay. Okay, now it says find, this is angle FDB. So from F to D to B. Okay. So let's redraw this FDB triangle. I'm going to redraw this over here. Okay, so let's try to keep as many things in the same orientation as we can. So we've got FB. So there's F, there's B, and then let's go straight over to D. And then we'll connect F and D. Okay, so the nice part is, look, we already found out what BD was, so we know that this length down here is 18.4. FB we know is 13. And it says find the angle FDB. So from F to D to B, we want to figure out what that angle right there is. So from this angle, that's the opposite side. This is the adjacent side. So theta is going to equal opposite, which is 13 over, tangent is opposite and adjacent, right? Tangent, theta equals 13 over 18.4. Okay, so we're looking for an angle. So we got to do second tangent of 13 divided by 18.4, and that gives us 35.2, we'll call it. 35.2 degrees. Okay? Okay. Last one to take a look at here is 22. Rico is flying his kite with the aid of a southerly wind. He has let out 34 meters of string, and the kite is an elevation of 37 degrees, and that's supposed to be to the horizontal. Okay, so it's making an angle of 37 degrees to the horizontal. His friend Edward stands to the west, 65 meters away. How far is Edward from the kite? So here's what we kind of got to look at here. Let's see if this helps out. So this is really, Edward is standing over here, and then the kite is straight out at a 90-degree angle from Edward to Rico. So Edward to Rico to the kite, this right here is going to make a 90-degree angle. Okay, so if we draw this like this into this 3D kind of shape here, that might help out. It might not, but hopefully it does. So you can at least kind of picture it a little bit better. Okay, and then we got, erased part of the kite. There we go. So that goes straight down, makes a right angle there too. And then we can go over. Okay, just so you can kind of get an idea of what's going on here. Okay, so I obviously didn't quite make this right. This is supposed to be a little bit more angled in and up so that this line and this line should be parallel. So at least you can kind of get an idea. Okay, so how far is Edward from the kite. So we got to figure out what this red diagonal line here is going to be. What is that length? That's what we're looking for. So we're going to need to figure out some other stuff here first. We do know, actually we might not have to. Let's see, we know, let's do this. Let's draw this triangle right here, because we know that that makes a nice right triangle here. So if we are, again, looking down on top, we've got, oops, sorry. We've got Edward is here, Robert is here, and then we got his kite is up here. So really it makes this right like this. Okay, we know the distance from Edward to Robert is 65 meters. We know that the distance from Robert to the kite, because that's how much string he's let out, that's 34 meters. So then we just have to figure out what this is. So we can just do a squared plus b squared equals c squared, right? So 65 squared plus 34 squared equals c squared. The one that really matters is the hypotenuse has to be across from this right angle. Okay, so we do that on our calculator. 65 squared plus 34 squared. Give us a big number, 5381 equals c squared. So we square root both of those to figure out how far Edward is from the kite. Okay, so we simply square root our answer, and we get that Edward is about 73.4, is this what, meters? Yep, meters away from the kite. So 73.4 meters. Okay, and then the second part here says, what is the angle of elevation from Edward to the kite? So now that's a different story here. We've got what we've got to do. Let's do this in, that's, again, I don't like, let's do this in green. Okay, so what we got to figure out now is we got to figure out what angle the red and the green line make. So we got to figure out what is that angle. That's the angle of elevation from Edward to the kite. Okay, the good news is we just figured out what this distance here is. This is 73.4. We don't know, oh, sorry, no, that's not what we just figured out. Sorry, we figured out this up here is 73.4, right? The distance from Edward to the kite. Okay, we don't know what this is, and we don't know what that is. So if we can figure out what either one of those are, then we're in business. Okay, so here's really kind of what we're looking at here. Let's do this. I guess this is the green one, so we'll do this in the, I'm going to redraw this triangle over here. So we've got Edward, Richard. Actually, it's not. Let's call this let's call this B for base underneath the kite or something like that. So this is actually a B from Edward to the base of the kite up to the, oh nuts, I'm trying to make a nice straight line up to the kite. We are trying to figure out what this angle here is. Okay, we know that this is 73.4, and we need to figure out either this or this. Let's see, I'm going to suggest that we figure out what this is right here, because with this triangle right here, the RBK, let's see, we know that this is 37, and we know that that's 34. Whew, that's a lot of stuff. Okay, so I'm running out of colors. So with this triangle here, this purple triangle, and that's angle 37 is right in here, and this is 34, and we want to figure out what that is right there, right? So that is opposite. This is hypotenuse. So let's do, that's going to be sine. So we would want to do sine 37 equals opposite, which is question mark, over 34. So if we multiply both sides by 34, then that'll tell us how high this is, and that's going to be this piece right here, right? So 34 sine 37 gives us that height is 20.5, we're going to call it. So this is 20.5. So that's going to be this part right here. So now, from this angle here, that's the opposite. This is the hypotenuse, so we can do sine again. Sine theta is opposite, which is 20.5 over 73.4. So since we're looking for an angle, we would do second sine of 20.5 divided by 73.4. And that gives us 16.2 degrees for our for the angle of elevation from Edward to the kite. That's a tricky one because you had to do all sorts of triangles to figure that out. Okay, that's all we have for the 7E Part 2 assignment. If you have any further questions on this or anything else, please feel free to ask. Thanks.